Thank you for joining this lesson. We're going to look at linear programming. We are told that Mr. Mairura has two lorries, A and B, used to transport at least 42 tons of potatoes to the market. So lorry A carries 4 tons of potatoes per trip, while B carries 6 tons of potatoes per trip. Lorry A uses 2 liters of fuel per trip, while lorry B, it should be B, while lorry B uses 4 liters of fuel per trip. The two lorries are to use less than 24 liters of fuel. Less than 24 liters of fuel. The number of trips made by lorry A should be less than the number of trips made by lorry B. Lorry A should make more than 4 trips. Taking X to represent the number of trips made by lorry A and Y to represent the number of trips made by lorry B, write the inequalities that represent the above information. So to represent the above information using inequalities, we're going to say, because X represents lorry A, then we're going to say, you know, this lorry is carrying 4 tons per trip. So if we say the trips by A are X, then we'll have 4 tons times the X trips. We add to the 6 tons of B multiplied by Y trips, and now the total number of tons are at least 42. So if they are at least 42, then it means this summation is either 42 or greater than 42. This becomes our first inequality. We continue and find that lorry A uses 2 liters of fuel per trip. Then B uses 4. So 2 times X trips. Then the other one is 4 liters times Y trips. This is supposed to be, because we have said the two lorries are to use less than 24. So this is either 24 or something less than 24. So this becomes our second inequality. We continue. We are told that the number of trips made by lorry A should be less than the number of trips by B. Therefore, the number of A are supposed to be less than the number made by Y. This is our third inequality. We proceed. We are told that lorry A should make more than 4 trips. So lorry A, the X trips should be more than 4. Not equal to, should be more, strictly more. So this is our fourth inequality. So after making the inequalities, we are told to plot the inequalities on the grid provided. So we are going to plot these inequalities, and as I said, we plot what we call the borderlines, whereby we substitute the inequality signpost with an equal sign to have borderlines in form of equations of straight lines. Therefore, I'm going to draw the graph here. Remember to subscribe to this channel and to share the link with friends as we continue studying together. So we're going to have 0, then 1, 2, 3, 4, 5, 6, 7, 8. Then on the other side we will have 1, 2, 3, 4, 5, 6, 7, 8, and such. We can adjust the axis as we continue. So one of the borderlines, because X is greater than 4, the borderline here will become X equals to 4. Therefore, line X equals to 4, we produce it. That is the borderline for the last inequality there. So this is line x equals to 4. Another borderline is x equals to y. X equals to y. So x equals to y is when x is 1, y is also 1, x2, y is also 2, x3, y is also 3. So we produce that borderline. Something to be noted is that the last two borderlines are just, this is greater than, there is no equal to, and this one is less than, and there is no equal to. So these borderlines are not going to be complete lines. We're going to have broken lines. So this line is going to be broken. A broken line. This is going to be a broken line. So this is line x equals to y. Line x equals to 4 should also have been broken. So we're going to have a broken line and not a complete line. It was just an oversight. Make sure you have it broken. Make sure you have it broken. So those first two borderlines are broken. Then we proceed to the second borderline here. So we're going to have 2x plus 4y equals to 24. 2x plus 4y equals to 24. So we can have a table for this third borderline of x and y values, and we see if x is 0, what is going to be the value of y. So if x is 0, I can see we have a 0 here, and the value of y will be 6, because we are going to, yeah, it is going to be 6. Then if x is made to be a number like 2, for example, this will become 4, and we subtract 4 here. So that now we will have 4y equals to 20, and y will be 5. So we can use those two coordinates to come up with a borderline 0, 6, 0, 6, and 2, 5. 2, 5. These coordinates. So when we produce that line, actually the borderline this time round should be complete. So we're going to combine the two. So this is going to be our line. That is going to be the borderline. Line 2x plus 4y equals to 24. And finally, we have the first borderline. The first borderline, which is 4x plus 6y. 4x plus 6y equals to 42. So we can have x and y again a table such that when x is 0, y is going to be 7, because we'll have 6y equals to 42. Another value, you can use another value like when y itself is 0. When y is 0, remember this becomes 0, so 4x equals to 42, and 42, when we divide it by 4, we're getting 10.5. So we have 0, 7, 0, 7. Then the other line should be, it means we'll have to extend now this axis to 10, 12, 13, and such. So that we will have 10.50. So this is 10, this is 12. So 10.5 will be at that point. So 10.50, we connect it with the other intercept there. So 10.5 is here, and this one is 7007, that is. So that is the other borderline. This is line 4x plus 6y equals to 42. So we have the borderline ready there. The borderline is ready. So we have all the borderlines plotted, and we can see there is a common region getting bounded here by the lines. So it means for this line we have to shade this part. It's the part we should shade. Then for the other lines we shade the outer sides like that. And now that for this lower side we don't have a borderline, we are going to shade the lower side of the x-axis, because according to the information we have, the number of trips made by A are supposed to be okay, the number of trips made by Y should at least more than 1. So x equals to 0 and downwards should be shaded. Therefore, we require the parts whereby Y is positive. Y is positive. So now this is our required region. And after getting the region, the last thing we're going to do here is to maximize and minimize. Or rather, we are going to do what we call now optimization. We are told that lorry A makes 35,000 per trip and lorry B makes 28,000 per trip. Use the graph above to determine the number of trips made by lorry A and lorry B to deliver the greatest number of potatoes, and hence find the maximum profit. So what we're going to do, we can see we have several combinations of trips in the required region. We have all these coordinates, all of them. All these coordinates are giving us possible combinations of trips made by A and B to deliver a given number of trips. So all these values inside the required regions are favorite. They're favorite combinations. But now we need the one that gives us maximum profit. So maximum profit means the greatest number of trips. Yeah, the greatest number of trips. Then later on the greatest profit. Therefore, we're going to identify what we call the objective function, which is going to be 35,000. So we write 35,000 for x, because it is A, and 28,000 for y. 28,000, I think they are thousands, yeah, for y. So this one will be the objective function. So what we do, we use the objective function to get what we call the search line. How do we get our search line? Our search line, we change the coefficients for y and that for x, such that now we are going to write two intercepts of the search line, but with the x-intercept taking 28, because we have to interchange them, and the y-intercept taking 35. Now, these values are so big for the axis we have, so we divide them with a certain constant uniformly, such that we can see 1,000 can simplify out. Then again, we can also go by 7, getting 4, and by 7, 5. Therefore, the search line will have x-intercept of 4 and a y-intercept of 5. So x-intercept of 4 is here, and y-intercept of 5 is here. Therefore, when we connect those two, we get the search line, and we are going to use it to maximize. So it should be noted that this now becomes our search line. So from the search line, now we can obtain maximum profit, minimum profit, and all possible number of trips made by each. Therefore, we are going to set our set square such that the longer edge is in line with the search line. Then we support the set square with a ruler on this edge such that we slide the set square in a manner that it will continue being parallel to the search line until we enter in the required region. Then inside the required region now, the first combination we meet will give us the minimum number of trips, which leads to the minimum profit possible. And when we continue sliding inside the required region, the last combination we encounter gives us the maximum profit. So this is what we call maximization using a search line, a set square, and a ruler. Therefore, on the search line, my set square is aligned. I support it with a ruler. Then I slide it into the required region until I see the last. And the last is becoming 9. This one, the last in the region. So this is becoming 9 and 1. So I'm getting 9 and 1. So 9 and 1 means a profit of 9 by 35,000 for X plus 1 by 28,000. So this is going to be, when we take 9 by 35,000, then we add 28,000. This is going to give me 343,000 Kenya shillings. So this will be the maximum profit. This will be the maximum number of trips, which is 9 from A and 1 from B, which is 10 trips